This is the most anticipated video in the series because we're finally going to add the most exciting part. The animatronics moving from room to room until finally they get to you at the security center and then they jump scare you. We're going to have two animatronics start on the stage, our Foxy animatronic and our Pug animatronic. They're going to move across multiple different rooms, each making their own choice on where to go. Static will appear and pop up to hide their movement so the player doesn't know what's happening. This episode is going to build on top of all of the prior work we've done, so if you haven't watched the rest of the series, make sure you go back and get up to this point. You're also going to need a fair number of assets, and that's why this video took so long to release. And that's where we're going to begin with this video. We're going to go into Autodesk Maya and see my scene setups. If you followed this channel, then you know I had a previous series where I made a 3D version of Five Nights at Freddy's. And so far, I've been using a lot of those assets to fill in all the gaps as I make this new 2D series. Here we are in Autodesk Maya. You don't have to use this program. You can use Blender, you can use 3D Studio Max, or whatever 3D authoring software you prefer to use. Here you see Pirate's Cove. It's an asset I created a long time ago for my 3D VR version of this game. I took the curtains and I duplicated them and moved them off to the left and to the right. Because the camera angle, where it's looking in this scene, will only see curtain, I didn't need to fill in anything else. I then loaded in my different animatronics. So here we can see both the Pug and the Fox. Now for this workflow, I decided to use the Arnold renderer, and most of these assets weren't set up to be used with it. So I did have to go through and retexture everything inside of Maya using Substance Painter. After I composed the scene, set up my lights and my cameras, I then created renderings of my animatronics in the location. Let's go through those really quickly. I started by creating the empty scene. I'm also using a cylindrical camera inside of Maya, which allows me to get angles that are greater than 180 degrees. This way I can get that wide angle zoom effect that we want. I went ahead and added Foxy into the room. You'll notice that this is an updated version of the Foxy model. I also added pupils so that he can look in different directions. Then I went ahead and added our Pug 3D model. One thing you're going to notice really quick is that with the Pug being here, we get reflections on the metallic surfaces of Foxy. This is why I ended up rendering out 4 different images for each room. You could also do this by layering them one on top of the other. The next really important room was bathroom hallway. This was another asset I took from my old 3D version and I updated it to work with what we're doing. In fact, almost all the other locations are based on this hallway, just from different angles. I wanted it to be kind of fun, so I literally put it on the wall. Here you can see something I'm not completely happy with. It's the Foxy model, dead almost center in the image, and it's taking up a lot of space. The pupils are very prominent with that sort of weird bladed look. One thing you'll notice about the Pug in every single scene is I kind of made up this lore in my head that the Pug is broken. It's falling apart because I never modeled the legs, and actually the hands are kind of a mess as well. Now the story is the Pug has to brace itself against a wall or other objects because it doesn't actually have feet to walk on. The supply closet is actually a room I fully completed in my old video series. What I've done here is I've added a nice light. I also added a bloom effect so it kind of blows out everything. Here we can see Foxy in the scene, and then we have the Pug again, this time bracing itself against that back cabinet that's holding all the different supplies. Next up we have the east and west doors. I distinguish them by changing the lighting. Here in the east door it's a kind of a blue light, and we've got this security no access sign. Here we have Foxy kind of off on the side. We have the Pug over here with its big face staring right at you. Not really a fan of this, so I actually went back and redid some of these renders. Here's my alternate renderings. You can still see Foxy there, but it's very dark this time, very hard to see. And then the Pug now is facing away from you, towards the door like it's ready to grab you. And here's the west door. It's the same model, but I've swapped out the signage so it says stop, and then now we have a red light, which kind of makes a creepy, eerie mood. Here we have Foxy. This is probably the creepiest one of Foxy so far. It's got its mouth open. It's really well lit, but it's still dark in the room. And then we have the Pug once again holding itself up against those side walls. Now that I have all those renders complete, we're going to add them into our Unity project. The first thing you're going to notice in our Unity project is we now have an Animatronic System game object, and that holds our new script called Animatronic System. It has 2 references, and these are to the jump scare sequences that we had previously in our level. Before, you controlled them by pressing a button on the screen to make the jump scare happen. We don't want that anymore. Instead, when the animatronic gets to the security room, it's going to automatically trigger that jump scare sequence, so we need to have a reference to it. Now let's take a high-level look at this code and go over how everything functions. So this is our animatronic system. We've got those two references to the jump scare sequences so that we can control when an animatronic jump scares at you. We then have two enumerations. The first is room state. This describes if it's empty, if there's a pug, Foxy, or if they're both inside. Then we have the room ID. Every camera we have has an associated room ID identifying it as either the stage, hall, supply, west, east, or office. If you have more rooms, you can add more of them here. Next up, we have some getters to make access easy. We have our pug room ID and our pug next room ID. The way things work is our pug decides to move to a new location. When it decides to move, static is going to fill the screen, and then after a certain amount of time, it will then move to that next destination. We do the same thing for Foxy as well here. We also have two bools. These Boolean values store whether or not the animatronic should stop moving or continue moving. This is so that when other things in the game happen, we can pause the animatronic and its logic so it doesn't keep ticking away and deciding to move from one place to another. We then have several floating point parameters. These store our timer for every time we want to move Foxy. We also have timer variability. This is how much variation there should be between every time the animatronic moves from one location to another. We then have our transition duration. This is how long it should take for a transition to occur. The static pops up, the animatronic waits, and then finally moves after 5 seconds. Then we have time to room change. This determines how long an animatronic stays in a room before it decides to move to another one. 10 seconds is very short for a real game. You're going to want to increase that when you actually try to play this. We have three very important events to go over. These allow the rest of the game systems to know what's going on with the animatronic. The first is onAnimatronic prepare to move. This lets everyone know that the animatronic is preparing to go to another location. Next up is onAnimatronicMoved. This allows the other systems to know that an animatronic has now moved from one place to another. And then finally we have onJumpScare. We want to tell everyone out there when a jump scare occurs. In our awake method, we set up that all the animatronics are starting on the stage, and we also initialize those timer values. In start, we register ourselves with the power manager so we're aware of when power outages occur. If a power outage occurs, in the previous video, we had a 50-second long sequence where we had lights go out, fans wind down, and all kinds of stuff happen. If we don't turn off the animatronic system, it will still think it's moving through the place even though the power's out, and then you'll get a jump scare unexpectedly in the middle of that sequence. Here you can see when a power outage occurs, all we do is we set the game object equal to false. We turn it off so it no longer runs the update method. In the update method, we subtract the amount of time that has elapsed, so we're getting closer and closer to 0. And then the two if statements are almost identical, one for the pug and one for Foxy. The pug one sees whether or not we're not paused, that is, the animatronic is functioning, and then it has a pug timer. If that timer goes below 0, we calculate our next location, and then we go ahead and call the event onAnimatronic preparing to move, so all the other systems know that this animatronic is about to move around. We then pause our pug because we don't want it to do anything while it's in that resting state. And then finally we call a coroutine unfreeze pug. This is going to wait until the static goes away, and then it will move the pug for us and unfreeze it. Foxy is exactly the same thing. The only difference is I added this timer variability part at the end so that it moves a little bit differently than the pug, and they don't always move in sync. The coroutine for unfreezing the pug and Foxy are almost the same. They both wait for a few seconds, that transition duration. They then choose a new pug timer or Foxy timer duration so that they all move a little bit differently. They unfreeze it. They then call or invoke the onAnimatronicMoved event so that everyone else is aware that things have happened. And then finally, we move the pug from one room to another by setting its actual ID. Then, if we find out that the pug is inside the office, we go ahead and invoke a jump scare. Foxy is once again the exact same thing, it just all pertains to Foxy. The getRoomState method is a public method for other classes to get the state of our current room. That is, to query a specific room and find out, is it empty, is Foxy in there, is the pug in there, or are they both in there? This is going to get used later by our camera manager to decide what image to show when we click on a room. Is Foxy there? Well, if Foxy's there, we need to show the Foxy image. Then we have calc pug next location. This checks our current room, the room we want to go through. It finds another room from some logic that I'm going to show you on what room to move to, and then it swaps that stuff out for us. Get next pug room and get next Foxy operate almost the same way. We have a switch statement that looks at the current room we're in. And it then says, well, if we're in the stage, we can only move to the hallway. If we're in the hallway, we've got some different events that can occur. We get a random value, and if that value is below 0.5, well, we see, do we want to go to the east or the west door? We once again check for a random value. If it's less than 0.5, we go to the east door. If it's greater than 0.5, we go to the west door. However, if it was greater than 0.5 here at the beginning, we go to the supply room. This allows our animatronic to have some randomness in its pathing. Now, if we're in the supply room, we always go out to the hallway. That's just it. If we're in the west door, we can either go back to the hall or to the office. Same thing for the east door. And if we're in the office, well, we should have already had a jump scare go off, so we just stay in the office. We can't leave the office once we get there. Before we dive into the camera manager, which works with the entire animatronic system script, I want to go over the camera area controller script. The camera area controller script is one we created a while back when we did the map. If we go under the map itself in our scene, we'll see we have different camera objects. One thing you'll notice is that my map is completely different than last time. The reason is because with these new rooms and the new layout, my old map my son made, Arthur, just doesn't work. So I brought in this new map by making it in Photoshop, and I duplicated the different cameras we had and renamed them. I have a camera area controller for the stage, hallway, storage, west door, and east door. Let's look at the inspector first before we dive into the script. The camera area controller script now has all of the information about the room. So here we'll notice we have the room visual textures. Each of those textures I had created inside of Maya that are now in my project, I dragged and dropped into each of these different sprite locations. We also have a field for room audio. This is so that every room we look at can have a different background audio running. Finally, we have room ID, which ties into the enum we just talked about. Each of these rooms gets set to have one of these unique IDs. Now, looking at the camera area controller script, we can see those public texture references at the top for each one, and we have that public audio clip. There is no audio source on the actual UI elements. The audio source is held on the camera manager game object. Under the camera manager game object, we have the camera manager script and an audio source. This audio source is going to play the background noise or sound for each of the different rooms. We also have a camera pan controller that we'll get to shortly. This is going to allow us to pan left and right in our scene so we can look over the entire area of our room. Inside of the camera area controller start method, you'll see we grab a reference to the camera manager. The reason is because the camera manager is going to store a reference to every camera area controller inside of a dictionary. Just hold on for 1 second as I jump back and forth, but here's the camera manager again, and you'll notice this private dictionary where it holds an animatronic system room ID, so that's going to be like the stage or the supply closet or the east or the west area. And then it's going to hold with that a reference to the camera area controller object. Remember, the camera area controller object holds all the information about that room, all the textures, all the sounds. So we need to know what that stuff is, and we hold it in that dictionary so that later on, all we need to do is know that room ID, which one it is, to grab the reference and then use that information to play the sound or change our graphics. Let's go back to the camera area controller and finish up with that. So here it calls camera manager.register room, and it passes itself into it. Going back to camera manager, here's the register room method. We're passing our self into it. That is the camera area controller right here. And then we try to add it to the dictionary. It then registers that room and stores it for later use. Nothing else changes inside the camera area controller. So we can stop with that and move back to the camera manager now. The big changes for the camera manager are that we now include a reference to the animatronic system. Another big difference is that we now have a second static noise player inside of our scene. Looking at our scene, we see that we have a panel static camera and then a panel static. Panel static was the one we had before. If I turn this on, we can see all that static filling the screen. We were using that at the end of the game when we needed to show static on top of everything. The problem is it sits on everything in our user interface. It covers everything up. So I duplicated it and renamed it panel static camera. Now when we turn this one on, you'll notice it doesn't cover the UI elements. This allows us to put static up on the screen and the player can still use the map and all the other user interface options. So go ahead and just duplicate your old panel static, move it up the stack above your map. We make sure that we store the current room ID that we're in. This is where we are right now, what we're looking at. We need to know that information. We also have some audio stuff that I've added this time around. The first is our mouse over clip. I noticed that when we use the map, we don't have any audio feedback about when we hover over anything. So now we have a mouse over clip as well as a mouse click clip, so that when you press one of the camera buttons, you get a different sound. We have the audio source, which will play whatever room background audio clip is stored inside of the camera area controller. So there's a lot going on now in the start method. Not only are we setting up all the material stuff for the background, but now we're also grabbing the animatronic system, making sure we have a reference to it. And then we're subscribing to the following 3 events: the onAnimatronic preparing to move, onAnimatronicMoved, and the onJump scare. We're also making sure we grabbed a reference to that static noise player. And then finally, we grab a reference to the audio source attached to this game object. Let's talk about those events because they're very important. The first is our onJump scare event. Whenever a jump scare occurs, we want to make sure we turn off that noise. It's very possible we were looking at a camera and then the jump scare happens. And what would happen there is the animatronic would be on top of the noise. We need the noise to disappear and the camera to disappear whenever that jump scare happens, so you're back in the security room. onAnimatronic preparing to move is important because it cues us in on when we should have the noise pop up in front of a camera. We get passed to us the room ID of where you currently are. We check to see if it's in the office, because if the animatronic is in the office, you're going to get jump scared and the game is going to be over. We go ahead and find the camera area controller for the passed in room right here. That's why we stored all that stuff in the dictionary. We then set that one to is transitioning is true. We're storing the state of that object so we know whether or not it's currently transitioning from one location to another, and therefore we need to show static. And then we take a look. Are we currently viewing at this room that is transitioning? If we are viewing a transitioning room, we make sure the static is enabled. If we aren't viewing a transitioning room, we turn the static off so we can see whatever is under there. In onAnimatronicMoved, we also get a reference to that previous room, and we make sure we turn the transitioning off so that it no longer shows static at that location. Select camera has grown a little bit since last time. Because we're working with a 2D game, it doesn't really matter where we play an audio clip at. So I use the audio source.play clip at point to play the mouse click clip, so that when you press the mouse button on that camera, it then makes a clicking sound. It then looks to see whether or not the room has any audio. If it does, it grabs that clip and plays it using our audio source. We then make sure we store that selected room ID as our current room ID, and then we go ahead and call the getRoomState method from the animatronic system. Remember, that tells us, based on the room that I'm currently looking at, what is its state. It returns that state information, and I'm going to use that to determine what to show. First, I'm going to see whether or not that room is transitioning. If it is transitioning, I know I need to throw static up there. If it isn't transitioning, I just double check to make sure the static is off. Then we go into the switch statement, which looks at the state of the room and sees if it's empty, it has a pug, if there's Foxy, or if they're both of them in there, and chooses the appropriate background to show. The final thing we have is onMouseEnter, and this is new. I have to talk about adding this event in a second. This is going to play an audio source whenever our mouse goes over one of those little camera UI boxes. Once again, this just is a quality of life thing. I like it that if you move the mouse over these boxes, you get a little audio kind of reminder that there's something you can do there. Looking back at the Unity scene, if we go into our map and our cam stage, you'll notice that under the event trigger, which is something we added in our map video, we had the pointer click, so that when we clicked there, we would actually call this function. I've added a new pointer enter method, which also calls the cameramanager.onMouseEnter method. This is the method we just saw that plays the sound. So whenever our mouse goes over that part, it will then play the appropriate sound. Now I also had to make the audio for each of the different rooms. To make some of the different sound effects you see in the game, I ended up just grabbing random objects in my garage. So for instance, I took this fan and turned it on and held it up to the microphone, and that gave me kind of a whirling sound. To get the sounds of clicking on the different buttons, I just used this multimeter. And I recorded me spinning the dial. And then for some of the other clicking sounds, I grabbed some magnets and then just had them snap back at each other. Now let's quickly talk about the last class that I added, and that is on the camera manager, the camera pan controller script. We have a reference to our background, which is showing our room. We then have the shader property, which is called camera angle. You can get all those properties by rewatching video 1, and here you can see all the different ones that we have. In this situation, cam angle controls that property. We're going to be modifying that value to make us look to the left or to the right. We then have our min and max pan values. These values are really small because I stupidly made it inside the original shader without normalizing the values between 0 and 1. Therefore, if I move beyond negative 0.005 or positive 0.005, the image just gets stretched on to infinity. So I want to make sure you don't move outside those ranges. Then we have our behavior, which is our maximum speed that we can pan to the left and to the right, and then how far from the edge we need to be in order to actually move it. The update method is the most important part. That's where we grab the mouse location on the x-axis, and then we check to see whether or not we are on the left side or the right side. If we're on the left side, we're going to see how close we are to it. That's going to influence how quickly we move. And then we calculate our step, that is how much to move in that frame. And then finally, we use the move towards function to slowly move from our current location to our next location by that step size. Then we do the same thing on the right edge. Finally, we clamp that value to make sure it hasn't exceeded those minimum and maximum ones we talked about before, and we apply that value to our shader. Now let's go ahead and build out the entire project and see what we have. We've almost got a completely functioning game at this point. The only thing we're really missing right now are the doors themselves moving up and down, and then the lights. And that's something we're going to address in the next video. After that, there'll probably be one final video where we do a lot of cleanup. There's a lot of unfinished and unpolished parts to this game. We also haven't talked about how we're going to add additional levels after each night. As always, thank you all for watching, and I especially want to thank our Patreon creative tier members who make this video series possible. See you all next time. So long and goodbye.